More applications of exponential functions. So again, we have this y equals ab to the x, where a is your initial value, your beginning, and b is the growth or decay rate. How quickly is something increasing or decreasing? So this time, what happens if I'm giving you a percent increase or decrease? We can't just use the number as we did before. So last time when we had it doubles, we just said a 2 was our b and we moved on. Percents aren't quite that simple. So if you are increasing, you're going to be 1 plus the percent. That'll be our b value. If you are decreasing, it will be 1 minus the percent. But don't forget, we always need to change our percents into decimals. So for example, if I have 25%, changing that to a decimal means take your decimal place and move it 2 times to the left. So my decimal version is 0.25. Well, what if I give you 2.8%? Take the decimal. So in this case, my decimal is already given. It's right here between the 2 and the 8. I'm going to move it over twice. So in this empty space, we put a 0. So 2.8% is actually 0.028. We have to change percents into decimals to be able to use them in mathematical equations. So example 1. The median household income in the U.S. increased by an average of 0.5% each month between 1979 and 1999. If the median household income was $37,060 in 1979, write an exponential equation for the median household income for X months after January 1979. So I need to still find my two pieces. I still need A for the initial, and I still need a rate, which is B. So the initial is your beginning value in whatever you're talking about. So in this case, we're talking about household income. Well, it says the household income was $37,060 in 1979. So that is your A, $37,060. B is how quickly you are increasing or decreasing. So it says the median household income in the U.S. increased by an average of 0.5%. So since we are increasing, that means my B value is going to be 1 plus my rate. And in this case, my rate is that 0.5%. So I need to change 0.5% into a decimal. So that means take this decimal place, move it 2 times to the left. So I'm actually using 0.005 as my rate. So my B is 1 plus 0.005. Well, 1 plus 0.005 is 1.005. So my final equation, y equals A, 37,060, times my B, which is this 1.005, to the x. And it still makes sense with what we learned before because your B value is greater than 1, which means this is exponential growth, which still makes sense because we are increasing. Now, part 2 of this says, what is the median household income after 5 years? So this is where we're actually going to use our equation and predict. So 5 years, that is our x value. But we have to be careful because in our word problem, it says that x represents the number of months. But I'm telling you 5 years, so we need to change it. Well, in 1 year, there's 12 months. So to figure out our x, we actually have to take 5 times 12. The 5 years they give us times the 12 months in a year to give us 60. So our x is actually equal to 60. So when we substitute this number in, 37,060 times 1.005 to the 60th power. This will tell us the median household income after 5 years. So we're going to use a calculator to help us evaluate this. So first thing we're going to evaluate is this 1.005 to the 60th. So we're going to have 37,060 times. So 1.005 to the 60th power is actually 1.35. Then we can multiply these two together. So 37,060 times 1.35 is equal to 49,988.39. So the median household income was almost $50,000 after 5 years. Example 2. Your family bought a car 10 years ago. Since that time, the value of the car has depreciated 3% per year. If your family initially paid $79,000 for the car, write an exponential equation to model the value of the car X years after it was purchased. So we need an initial and we need a rate. So my initial was how much this car was worth when we bought it. And it even says we initially paid $79,000. So that's my A. Then my B is that rate. Now I have to first figure out if we're increasing or decreasing. So if we think about this, cars' value usually decrease as time goes on. But there is a word in here that will tell us. It says the value of the car has depreciated 3% per year. This depreciated means decreased. So I'm going to have to do 1 minus, since we are decreasing. Now, 3% needs to be changed to a decimal. So move your decimal place 2 times to the left, and you end up with 0.03. So we need 1 minus 0.03. Well, 1 minus 0.03 is equal to 0.97. So this is the B value we're going to have to use. So when we write our equation, A is the initial, that's $79,000. Then 0.97 is your rate of decrease, and then to the X power. Part 2, what is the value of the car today? Well, how long ago does it say we purchased this car? It says we purchased this car 10 years ago. And X is years, so that means our units match. So we can go ahead and use X is equal to 10. So we're going to substitute the 10. So 79,000 times 0.97 to the 10th power. And again, use a calculator to evaluate. So first thing is exponents. So 0.97 to the 10th power, when you evaluate this, you get 0.74. Then we can multiply 79,000 times 0.74 to get 58,256.51. So after 10 years, the car is worth about $58,000. Example 3. You take a 325 milligram dose of ibuprofen. During each hour after it's taken, the amount of medication in your bloodstream decreases by about 29% each hour. Write an exponential function that will give the amount of medicine in milligrams in your bloodstream after X hours. So the initial, A, that's the 325 milligram dosage that you took. Then it says during each hour after it's taken, the amount of medication decreases by about 29% each hour. That's our rate. So since we are decreasing, I need the 1 minus. 29% needs to be changed to a decimal, so move the decimal point 2 times to the left, and we get 0.29. So 1 minus 0.29 is equal to 0.71. So that's our B value, is 0.71. So substitute A and B into the general format, so 325 times 0.71 to the X power. Estimate how much medicine will be left in your bloodstream after 6 hours. So I'm given 6 hours, and in my original problem it does say that X is hours, so my units match. So that means X is equal to 6. So we're going to substitute X equals 6 into our equation. So 325 times 0.71 to the 6th power. So first, use your calculator to help you with the exponent. So 325 times 0.71 to the 6th, which will give us 0.128. Then we can multiply 0.128 times 325 to give us 41.63. So the amount of milligrams left in our body after 6 hours is about 41.63. Example 4. Jeanette buys a house for $130,000. The value of the house appreciates 6% per year. Write an exponential function that will give you the value of the house X years after it's purchased. So we need to find our initial. So the initial value of this house when it was bought was $130,000. That's how much we paid for this house. Then the value of the house appreciates 6% per year. So if depreciates means declines, then appreciates means increases. So we're going to have to do 1 plus. 6% needs to be changed into a decimal, so take the decimal place, move it 2 times to the left. We end up with 0.06. So we're going to have 1 plus 0.06. Well, 1 plus 0.06 is 1.06. So there's our b value that we're going to be using. Y equals 130,000 times 1.06 to the x. And there's the equation piece. So what is the value of the house after a decade? Well, x is in terms of years here. So a decade is actually 10 years. So we're going to have to use x is equal to 10. So y is equal to 130,000 times 1.06 to the 10th. Again, use your calculator to help you evaluate the exponent first. 130,000 times 1.06 to the 10th, which will give us 1.79. Then 130,000 times 1.79 is 232,810.20. So the value of the house after 10 years is $232,000.